Hey guys. Alright, this is the third installment on how to solve a system of equations using elimination, or what we also call linear combination. As we go through this, to begin with, the same idea is true. We're still trying to find a solution to where the two lines are going to intersect. But now we've got something a little tougher. As we look at this, the first thing you look for, again, first rule, is it in standard form? Ax plus by is equal to c. And they are. So that's a good idea. So once you know that, the second thing you try to do, you try to add straight down. Well, if we add right now, you get 7x, you get y is equal to 27. At no point do we eliminate a variable. Right, so that's where we have an issue. We talked about this in the last installment. Now you have to look. Is there a variable that has the same coefficient in front? The answer is no. So as you look at this, now we have an issue. With that in mind, what we have to do is now we have to manipulate one or both equations so that there is a variable with the same coefficient in front. And what we talk about is the least common multiple. That's already been discussed, and that's something if you need to go through again, you can ask about. What you're going to do is, if you notice there's not a variable with the same coefficient in front, we're going to draw a line down here and leave a space for both equations. At this point, you need to choose which variable you want to eliminate, which one you want to equal 0. In all honesty, it does not matter which one you choose. There are better choices, but no matter which one you choose, you will get the correct answer. What I try to look for is first off, opposite signs. The second thing I look for is I look at each set of variables and I look which one of those is already the least common multiple. So for example, if you look at x, the least common multiple is 12. Okay? That means you have to manipulate both equations. If I look at here, I have a 1 and a 2. The least common multiple between 1 and 2 is 2. No, this one already is 2. So for me, choosing y will make my life a little easier. So, I'm going to choose y to eliminate. Excuse me. Sorry guys. Alright, so from there, what I know is that I want y to be 0. So I put that down there. And then I look. If the least common multiple is 2, I know in the second equation, it already is 2. So I just leave the second equation alone. So I just rewrite it. Now, to get 0y, I need to think to myself, what plus 2 will give me 0? Well, a negative 2. So you want that to be a negative 2y. So what we do is we're going to manipulate and change the first equation so that this will say a negative 2y. And the way we do that is through multiplication. You can multiply negative 1 times negative 2, or times 2 to get negative 2. So if you have to multiply this by 2, that means you have to multiply everything in the equation to be 2 to keep it balanced. So watch. 2 times 4x is 8x. 2 times negative 1 will give you the negative 2y that we want. And 6 times 2 is 12. So now we've changed that first equation. From that, we can add straight down now. Watch what happens. 8x plus 3x is 11x. Negative 2y and 2y is 0y. And then 12 plus 21 is 33. So now we've eliminated, excuse me again, we've eliminated y. So as we can see, it's gone. We just have 11x is equal to 33. Now we're just going back to what we did before on any of the other problems. Divide both sides by 11, x equals 3. So you have the x coordinate. Right? You still need to find the y coordinate. So from here, I'm going to take that, I'm going to substitute it into the second equation. And we use the original equations to substitute back into. You don't want to use the ones you did before. Not that you won't get the right answer, it's just some of these will get larger and larger. So I try to use the original ones to find the second part to your equation. So 3 times x, which is now 11, plus 2y equals 21. 3 times 11 is 33, plus 2y equals 21. Two-step equation at this point. Add negative 33 to both sides. That's 0, so you get 2y is equal to negative 21 minus 33 is a negative 12. Divide by 2, and y is a negative 6. So, if you drew these two lines, they would intersect at the point 3, negative 6. Let's try another one. So you got 9x plus 8y is equal to 19, then 4y plus x is equal to negative 7. Got an issue here. Not in standard form. The first one is, oops, sorry. Negative 9x plus 8y equals 19. The second one, we got to switch these around. X plus 4y equals negative 7. So now we can start. Always remember to make sure it's in standard form. So if we add right now, you'll get a negative 8x and a positive 12y. Do not eliminate a variable. If you look at both of them, you do not have a variable that has the same coefficient in front. So we have to decide which one we want to eliminate. And all in all, it doesn't really matter which one. You can choose x or you can choose y. Alright. I'm going to choose x, so I'm going to eliminate x. The least common multiple between 9 and 1 is 9. So the first one is already a negative 9x, so it already has that least common multiple in there. So I can leave the first one alone. And the second one though, I need to get 0. So you got negative 9x. What do you need here to get 0x? Well, you need a 9. Negative 9 and 9 will give you 0. So I need to multiply this second equation by 9. And that means everything in the equation by 9. 9 times x is 9x. 9 times 4y, positive 36y. And then negative 7 times 9 is negative 63. So from there, I add straight down. Negative 9 plus 9 gives me the 0 that I want. 8y plus 36 is 44y. And then 19 minus 63 is a negative 44. That's 0. So all I have left is just 44y equals a negative 44. Divide both sides by 4. Y is equal to negative 1. Alright, so you now have y. You still need to find x. So what I would choose is one of the two original equations. I would actually substitute it into the second one for me. So I would write out 4 times negative 1, which is y, plus x equals negative 7. You get negative 4x plus, or negative 4, sorry, plus x equals negative 7. Add 4 to both sides. That's 0, so you get x is equal to negative 3. There you go. So now, if you were to graph these two lines, they would intersect at the point negative 3, negative 1. Alright. Next one. So when we look at this one, same idea as before. Is it in standard form? Yes, it is. So being that it's in standard form, what we want to do is we want to try to eliminate a variable. Again, it does not matter which one you choose at this point. All right. I personally will choose x. The reason why is I like the opposite sides. The least common multiple for 6 and 4 is 12. The least common multiple for 3 and 7 is 21. I'd rather work with this one. So, I know I want to get 0x, so that's why I put that there. Now, neither of these have the least common multiple. So, when I look at this, I want the first one to be positive because it already is positive. So I need to make this first one 12x. The second one, I want to make that one a negative 12x because it's already negative, so I'll just be able to multiply by a positive number. As I look at this, what do I have to multiply this that first equation by to get 6x to be 12x? Well, multiply by 2. So that means you got to multiply the whole thing by 2. So 2 times 6 will give me the 12. 2 times 3y is 6y. And 2 times 27 is, what is that? 54. There you go. Now the second equation. When you look at this one, we're going to multiply this one. Negative 4 times what gives me negative 12? A 3. I multiply the whole thing by 3. 3 times negative 4x is negative 12x. 3 times 7 is 21. So I get 21y. And 27 times 3, that ends up being 1, 81. So, you've now manipulated both equations to get this least common multiple of 12. Now when you add straight down, you can eliminate a variable. So 12x negative 12x is 0x. 6y and 21 is 27y. And 54 plus 81 gives you 135. Alright? That's 0, so it's gone. So we just divide both sides by 27. 135 divided by 27 is 5. So from there, we have the y coordinate. Still need to find the x coordinate. So I'll plug this in, I'll probably use the first one. So I'll write 6x plus 3 times 5. Y is now 5, not a 7. And that's equal to 27. So, you go through, and let's work it out. 3 times 5 is 15. Right. Add negative 15 to both sides. That's 0, so you get 6x is equal to 12. Divide by 6. X equals 2. Alright. Let's try, we're going to try this one here. So, let's take a look at this one. I'm sorry, I want to try this one. This will be the last one we do. So as we look at this one, as we look at it, if we add right now, we not eliminate a variable. It's in standard form, so we're good. But now we have to figure out which of these would be which one do you want to eliminate? In the end, it doesn't matter. Let's say you want to eliminate y. What the heck? We'll eliminate y in this one. So, as you look at this, between 6 and 3, what's your least common multiple? 6. So the first equation, that's great. It's already a 6. So we don't have to do anything to the first one. The second equation, though, to get 0y, we want a negative 6y there. So, negative 3 times what gives me negative 6? Well, a 2. There you go. So, let's multiply it out. 2 times 2x is 4x. 2 times negative 3y gives me negative 6y. And then 4 times 2 is 8. Alright, add straight down. You get 0x here plus 0y here is equal to 14. Well, here you eliminated both variables. So 0 plus 0 gives me 0. Alright. Ladies and gentlemen, this is a special case. Special case is we've eliminated a variable. There's no more variables left. And we ended up with now 0 equals 14? No. A false statement. We've talked about this before. If you eliminate your variable, you end up with a false statement. The answer is no solution. Now remember, the reason why it is no solution. If you were to put both of these equations in slope-intercept form, you'd see that they have the same slope, but a different y-intercept, which means they are parallel. These two lines will not intersect, which, as we talked about before, the solution to a system of equations is where the two lines intersect. These two lines will not intersect, so you cannot get a solution. So, if you eliminate both variables, and you end up with a false statement, the answer is no solution. On the other side of that, if you end up with a true statement, like 0 equals 0, that means it's the same line. So that means the answer is many solutions. There are infinitely many solutions. That means it's the same line. Okay? So I want to make sure you see both cases. All right? Remember, 99% of the time, you're going to see one solution. All these are all one solution. We have no solution and many solutions as options. All right, ladies and gentlemen, hopefully that helped out. You guys have a good evening. Bye.